Hello, welcome to mydeepguide. My name is Voya, and to a slightly different angle. Currently, I'm working on a new thing that I was curious to test out. It has to deal with privacy analysis of different devices and different platforms. Basically, trying to kind of see how much do these devices or different platforms talk to the outside world. Who are they talking to? In which situations are they talking to? I have here the iFlyTek AINote 2 in front of me because I was interested to see where and how much does this device and platform communicate, because it depends so much on the account and the online functionalities. So that's where the whole kind of journey started, but naturally it evolved into a project, and then I ended up designing it, writing it, and making a script and a whole methodology, and basically having a set of 15 tests that I perform in a controlled type of environment, control setting, and evaluating a test result from those tests, and something that I can hopefully actually apply cross-platform. So while I'm going to start with the iFlyTek, I'm going to be, in the same video, I'm going to be testing it out on the Boox device as well, so that we can actually compare and see how much do these devices talk to, where do they talk to, and what kind of insights this kind of procedure can actually give us. Since this is the very first time that I'm actually mentioning this methodology, just a brief kind of info on what it entails. If you are interested in more information about the testing, I will include, I hope, by the time that this video comes out, that I will have some documentation already prepared so that you can actually access a document that details the testing methodology itself. And if I actually have enough time, I'm hoping to, at some point in the future, to add a section to the mydeepguide.com website where you should be able to kind of go and check out the privacy analysis comparisons for different devices. However, that may not be available yet by the time this video comes out, but it's a hope that I'm kind of leaning towards and should be available at some point in the future. So privacy analysis workflow or tool using Wireshark on my desktop computer to capture the network communication, all of the network communication from the device. The goal was to isolate the communication just of the device itself, and that is achieved. It can be achieved in two different ways. For me, the simplest one and the cleanest one was actually using a mobile hotspot on my PC, and the only device that connects to that hotspot is the device that is being tested. Once I've established that, I did a thorough check with the Wireshark to test the hotspot. Does it bleed a lot of nonsense or not? And if there's like any kind of chatter, thankfully there was basically virtually zero, which is a great state to be, because any and all communication is then completely isolated to be captured from the device itself and nothing else around to, cause noise. The test itself consists out of, as I already mentioned, 15 different types of tests, and I'm going to be reading them off the screen here, so that's what I'm looking at. So the first one is device Wi-Fi connect. So that is from the disconnected state, we press connect and it connects, and we capture the initial state of connecting and immediately after connecting what the device is actually doing. And this is performed for a limited amount of time so that it doesn't interfere with the next portion of the test. And the second portion of the test, separate one, is going to be idle state of the device. What's it doing? Who it's talking to? How often it's talking to? And in this portion of the test, I leave the device for 10 minutes uninterrupted, not going into a sleep mode, just to kind of do its thing, and I keep capturing to see what it actually is doing after it's been started and, while it's idling, just to kind of gain insight. Then a test 3 is to do the same thing, but with the screen off. Ideally, when you put the device in a screen off or sleep state, it shouldn't talk to anyone, but that doesn't necessarily always have to be the case, and that's the part of the test that monitors that. Then we have 4 with the Wi-Fi off transition. We just toggle off Wi-Fi and see how the transition looks like, what the communication is, and is there anything suspicious in there or not. And once it's actually in the off state, we stay for about a minute or so just to see like, is it truly in a Wi-Fi off state or not? And then we repeat the idle screen on and off in tests 5 and 6, but this time with Wi-Fi off. The same thing applies, except this time it's a much shorter type of test because naturally, if it's a true Wi-Fi off state, we should end up with 0 type of communication, and any type of communication that happens is going to rear its ugly head very, very shortly. So there's no need for a 10-minute kind of a test. Tests 7 and 8 regarding the reading operations of a local document. So I open up a local document, just a document that's on the device itself, and I start reading for about 5 minutes. They are the same type of reading operations, but one is with the Wi-Fi on, the other one is with the Wi-Fi off, so that we can capture and see again the communication state of the device. And then we get the tests 9 and 10, which are note-taking, again with the Wi-Fi on or off. The important caveat here in both reading and note-taking is that no OCR and no AI functionalities are permitted to be executed while testing this, because I'm testing just the core raw app behavior of the reader and the app behavior of the note-taker and what it wants to communicate, who it communicates to, etc. This is not to say that I'm not going to be testing OCR, because I think it's an important one, especially because you have online-only OCR devices and offline OCR devices as well, which of course will have a huge impact on privacy considerations when you're thinking about different platforms. So the OCR testing in tests 11 and 12 are performed both with the Wi-Fi on and off, even with the devices that are explicitly just OCR online only. Why would I test OCR with the Wi-Fi off on a platform that's clearly online only? Well, because I want to see what it actually wants to communicate when it attempts to do the OCR recognition and then kind of figures out, hey, I'm actually offline. It's purely just to be thorough. Test 13 is testing one of the AI features if the device has an AI feature. But here I'm talking about the newer type of AI feature, something that the AINote has, for example, and other devices are starting to have that, such as, the most typical examples would be AI summary of a notebook or of a document. Naturally, at this stage of technological development, this is always going to be online-only functionality, so there's no point in performing an offline functionality test in this portion. And then finally, we have the background OCR recognition for the devices that have that. So quite a lot of devices actually are introducing the functionality of enabling that in the background while you're performing other tasks, that the device is actually performing OCR of your notebook or of your document and things like that to speed up your development. Not all platforms have that, but quite a few actually do have that. And that's what's tested here as background OCR. And this one is tested both with the Wi-Fi on and with the Wi-Fi off functionality, and that concludes all of the 15 tests of the privacy analysis workflow that I'm going to be doing today. Once all of that is captured, then I just run my super duper uber script that goes through all of the PCA PNG captured files from the Wireshark, and then it starts filtering based on the device's IP address, device's MAC address, what's important, what's not important. So quite a lot of kind of testing went into that to basically filter out meaningful stuff from noise. And once the script is done, it actually spits out the analysis summary file, which will consist out of final kind of scoring with the weighting that I currently have for typical typical things, and it's transparent on the results. You will see what the weighting is. There are bonus features, there are penalty features, and all of that kind of stuff. So that we will go through when we examine the final results. But spitting out that final test and summary of the test is basically the test conclusion, where it gives you all of the information about the test that is meaningful. An important part here is that the analysis actually extracts the domains that are most frequently communicated with in different types of states. So in idle state, in reading, in AI and stuff. And all of that is then kind of summarized in one place, so that anyone who's actually interested in this, that they can take a look and maybe take this examination further if that's something that they are interested in, or it can actually give you further insight into privacy related concerns that you may or may not have, but at least it'll give you more awareness into privacy related issues with different platforms and different devices. So that's the whole point and the purpose of the privacy analysis tool and the workflow. I'm going to start with the AINote 2 from iFlyTek. I'm going to be performing these tests, capturing them. Then I'm going to do the same thing for the Boox device. I'm going to grab my Boox Go 10.3 and perform the same set of tests on it, process the results, and then come back to you here so that we can analyze them and see what do we learn from them, how do they compare to each other, and see if this is meaningful, interesting, or not. I've done all of the 15 tests now on the AINote. Now I'm gonna be moving on to the Go 10.3, updated to the latest release, then restarted twice, so that we purge any of the post-update communications that could be going on. I'm gonna make the AINote forget the same hotspot network, and I'm gonna make the Go 10.3 forget any other wireless network, so that the only thing that it exists for it is this hotspot network, so that if it wants to go online when it's maybe not supposed to or anything like that, that the only source of internet that it can find is actually this controlled and monitored Wi-Fi hotspot. After that, let's process the data and then analyze it and see what do we get. I'm genuinely interested to see on individual basis how this turns out, and then especially on comparing these two, because this is the first time that I've ever tried something like this. So let's see how it turns out. Now I've completed the testing on the Boox Go 10.3 as well. And I'm just gonna reorganize the files locally and start the processing so that we can actually see what do we get. Let's first check out the results of the iFlyTek AINote 2, the privacy analysis results here. Report starts out with, let's zoom in a little bit more so that you can see a bit better, with the final weighted score, and it scored actually 74. And here is the breakdown where we have offline integrity score, cloud exposure score, and idle chatter score. If anybody is interested in how these are being weighted, I've decided on these weights, where the offline integrity is 35%, cloud exposure 45%, and idle chatter is 20% of the final score. So offline, it is a truly offline device, which is really, really good. Cloud exposure score, very, very low, which is not really surprising, to be quite honest, because that is the main concern about this device, that, it's relying on a lot of things, and when it's accessing the cloud, it's doing it a lot. The idle chatter score is at 70%. So now let's check out the modifiers. As the OCR capability is online only, it does not get a bonus. AI, obviously, it's online only, so no bonus here. So total bonus is 0, no adjusted score here. And here are the observations about the test. The device's network behavior was scenario dependent and repeatable within the captured windows. When Wi-Fi was off, network activity was effectively 0, so controls held. That's a really good thing to have. Network heavy traffic appeared tied to feature use rather than constant background streaming. This is exactly what we're looking for. So if you are going to have chatter back and forth, which is normal type of behavior for a cloud-based type of functionality. So yeah, obviously if you have online-based functionality, it's going to have chatter, but only when you are doing something. It's not a device actually doing stuff without your knowledge or consent for the most part, and that's a really good thing to see. No unexplained background exfiltration was observed within the captured windows, and that's also another positive thing to see. So we have cloud exposure scope. Cloud step traffic included both local and private and public internet destinations, to be expected. And then final recommendations in the report generated: do not treat this device as private by default. Assume OCR and AI features can transmit data to the public internet. Do not use them for sensitive content. That is just a general type of sensible type of thing to keep in mind. Obviously, when you're sending something to the cloud internet, it's no longer private. For sensitive notes and documents, keep Wi-Fi off and avoid cloud features. And this is actually pretty good, because then when you turn off Wi-Fi on this device, it truly is off. It doesn't try to sneak in kind of random connections or anything like that. When it's off, it really is off. And for low sensitivity use, such as reading, basic offline notes, observed behavior was controlled and scenario dependent, which means there was no random non-related type of network activity that the device was exhibiting while doing these types of activities. The category score breakdown with the offline integrity, excellent, as we've said. Cloud exposure 55, which is fairly low, and that is mainly due to this one. Cloud traffic was predominantly public internet. So it gets a -45 penalty for something like that. And in the idle chatter, it scored 70 out of 100. Why? Well, because of these steps here. So we had remote idle traffic with no DNS observed in step 2, which was the idle Wi-Fi screen on. So it gets a -12 points for basically being opaque about what it was communicating and doing with. We also get in the idle state as well, remote idle traffic with no SNI observed, -10 there, and many remote endpoints during idle, so that is -8 points. So it's still 70, so that doesn't mean that it's great at all. It does idle chatter, it's just that it doesn't do it a lot. But it's certainly not something that you can consider as foolproof or private by any means. Therefore, in this one it says do not treat this device as private by default. In the end, we have a very detailed breakdown for each of the steps that were done while testing. And this, I'm not going to go through all of this in super details. Instead, I am going to make this publicly available so that those who are interested, that they can actually study this and check out what they might be interested in. But just because this is the first time that we're doing this, I think that it's interesting to kind of check out where, you know, during the device Wi-Fi connect step, that's step 01, we have, these are the DNS names that the device was checking out and what it was mainly communicating with. We also have the step score, so each of the steps has that type of granularity involved. So then we have step 2, which is the idle Wi-Fi connected screen on, and this is the interesting one. We did actually have these guys here, which is still some type of communication that you need to be aware of. Therefore, we have remote traffic, but no DNS observed. Definitely a negative point, and therefore that's why it scores this kind of stuff. Idle Wi-Fi with connected but screen off, where the device should be in a true off state, and it scores 100 out of 100. So when the device is in a sleep state and with the screen off, it is truly off. It's not doing anything kind of weird, at least not in this 10-minute window. And furthermore, it was truly disconnecting Wi-Fi from the hotspot. And that's basically your blueprint on how to check this whole report out, if this is something that you are interested in. So you can clearly go through all of this and check out what it is that you are interested in. And yeah, it's free for you to peruse over. For me, the main thing is basically this summary, because that's how I made the whole thing, so that I don't have to go through it all individually unless I'm specifically interested, that I can actually rely on this main breakdown here. So that's the situation for the iFlyTek AINote 2. Now let's check out Boox 10.3, and let's put them side by side so that we can see how they actually compare, and if there are differences, what those differences are. All right, so we got the Go 10.3 on the left, on the right hand side, and the AINote 2 on the left hand side. So right out of the gate, well, we have different type of scores. And for some reason, Go 10.3 is actually scoring considerably lower, 57. So now let's dig in and see why. And immediately we actually got the offline integrity score really severely dropped down. It had quite a few more steps with 0 packets, while we had only the 6th step on the iFlyTek with no packets and no frames observed. On the Boox we had steps 6, 8, 10 and 12, so all the offline states were actually truly offline. So it leaves to kind of see like what the hell happened for this device to get that -70 thing in the idle state. So we have Wi-Fi Connect was 90 out of 100, which is identical to the iFlyTek. So okay, when you're connecting offline, online, it's pretty much exactly the same, but it's connecting to different and talking to different sites here, which you can clearly see. But we do have more transparency here than on the AINote 2. Now this is the one where I think things went wrong. So, or no, they haven't. Even in the idle state, that's actually when it was all okay, and it scores still higher than the iFlyTek because of transparency. Because now, while on the FlyTek we can't really see who it was talking to, here we have full transparency, and we have all of the DNSs and everything else kind of exposed, so that you can see who the device is talking to while it's in an idle state and how much it talks to these servers or sites. Then we have idle Wi-Fi connected screen off, 100 out of 100. Where the hell did it happen that we had this offline thing that was bad? 100 out of 100 for offline transition, idle Wi-Fi off, screen on, 100 out of 100. So 6 was an off state. Reading local Wi-Fi on, 90-10, we have 80-10. Okay, so close, but not exactly the same. Reading, that was no packets. That's actually excellent to see. That could be also very well a bug maybe, so let's see. I did some bug checking and there were 2 issues, and actually I was wrong. The first thing that I was thinking that was the cause of the offline capability calculation was wrong. It was actually something else. There was a miscalibration in the step 4, how it was calculated. So it was weighted like completely illogically. So I fixed that, and the second error was that the text files, or the best ones, the ones that had 0 packets, they didn't really give the end report correct scoring. So those 2 have been fixed. Consider it is taking a penalty offline integrity score. That was that step 4, which basically was sending some amount of data to Google Play Store before it went to a shutdown. So that was the one that caused a huge penalty, but it was way, way, way overweighted. In some sense, maybe that's an unfair penalty, that the device is supposed to kind of finish what it needs to do before it disconnects, because the platform actually asks for it. I'll have to think about it, because right now I'm giving it like a 15-point penalty. I think that's just an unfair penalty, because the device is just simply doing what it needs to do before it turns off, and once it's off, it's actually off. So let me adjust that, but I'm just doing all of this for full transparency, and I'm interested in your opinion. So I'm just gonna make a quick fix here and readjust the scores just to see the real reading, because this doesn't sit right to me. It doesn't make sense that a device, any device, any platform should be penalized for just cleaning house before turning itself off. Let's find where the modifier is. There we go. Offline transition public penalty. Let's move that to 0. 0 penalty for that, because transition should not be penalized. And now let's try it out and see what scores do we get. All right, so the final tally here, with not being overly brutal with a transition period of turning Wi-Fi off. I may as well change that at some point, but at the moment I think this feels most fair. I'll hear from you guys as well, because I'm genuinely interested in your opinion. Now the score for the Go 10.3 is 82 out of 100, with the offline integrity score 100 out of 100, which I think is a reflection of reality, because the device didn't send anything when it was offline and it turned itself offline. It was just cleaning house. Then we have this, and then we also have the capability modifiers, and how does that affect it? We got 87 out of 100 versus 74 out of 100. And I think that this is a more realistic reflection of reality, and more importantly, realistic reflection of individual step results, because the first one just didn't make any sense. There we go. We have my first attempt at something like this. This is obviously work in progress, as you guys can clearly see. But I'm interested in what your opinion is, what you think about this whole approach. Should the device be penalized when it's transitioning into an offline state if it cleans house before it switches Wi-Fi off, and then has 0 communication after it has actually switched the Wi-Fi off? I'm kind of curious as to what you guys think. I think this is, at least for me, a little bit informative and insightful. And in this case, yeah, between the iFlyTek AINote, that scores okay with 74 out of 100 in the privacy analysis tool, where the Boox Go 10.3 updated to the latest version of the 4.1.1 point something version of the OS, it scores 87 out of 100 in the privacy analysis here that I'm kind of developing. Next, I am interested to actually go ahead and check out the Remarkable platform. I think that's going to be an interesting one, because it's a completely different approach to this. And then the really interesting one is going to be the SuperNote bot. I'm going to pit SuperNote with their own cloud service versus SuperNote on your own private cloud service, where private cloud service, of course, is not going to be treated as public internet access, right? And the script is already made so that it separates public and private internet communication and deems it like that. So that one I'm going to be very, very interested in, but I'm also equally interested in the Remarkable itself, how their service is, who it talks to, where it talks to, how much does it talks to, and all that kind of stuff. Of course, the nicest thing of all would be if I were able to decrypt the packages and see exactly what is being sent in those packages, but that's beyond my capabilities to decrypt the encrypted packages at this point, but you never know. For now, that's the extent of my kind of nerding out with this thing. Please do let me know in the comments down below what you think, and is this something that you find interesting and or useful or amusing, or anything like that, and also yeah, maybe what other stuff you might be interested in seeing in this realm while I'm shaping up this privacy analysis tool for mydeepguide. Thank you so much for watching. Stay safe, stay healthy, and see you in the next video. Bye.